Okay, hello everyone in a new video. So we have reached part 2 of chapter 3, which is the chapter of velocity for grade 8 students. Then we have reached section number 5, and the title of this section is the speed. So what is the speed? The speed is a measure of how fast an object is moving with respect to time. Now, if you consider the adjacent document, we have two cars. So as it seems that they are racing up, so in order to compare which of the two cars is the faster one, so it's important that we define the speed. So what is the speed? The speed is a measure of how fast an object is moving with respect to time. And it's important that we distinguish between two types of speed, and they are given by. So let me say here that there is two types of speed. So the first one is given by the instantaneous speed, and the other one is given by the average speed. Then in this section we are going to introduce the instantaneous speed and the average speed. Let me start by the instantaneous speed. So let me write here that section 5.1, instantaneous speed. So it is the speed measured by the speedometer So consider the following, the adjacent document. So this instrument is known to be the speedometer. So this instrument is usually installed in different vehicles like cars, motorcycles, and even on the bikes. So it indicates or measures the speed at a given instant. For example, here if we are measuring the speed at instant t1, so the speed in this case is given by, if this is 40 and this is 60, so this is 50, then this is 55. Then in this case the car is traveling at a speed given by 55 miles per hour, or say for example 90 kilometers per hour. So in this case the speedometer is indicating the instantaneous speed. So what is meant by the instantaneous speed? It is the speed measured by the speedometer, or in other words it is the speed at a given instant. So for example in this case the speed at this instant is given by 55 miles per hour at the instant t1. We know that for another instant t2 the speed of the car may be given by 100 miles per hour or 30 miles per hour, so on and so forth. Okay, so the instantaneous speed is the speed at a given instant. Now, as for the second one, which is the average speed, Now if you consider the following adjacent document, we have a road, and suppose that we have an object like a car moving on this road. We know that the speed of the car in this case may changes. For example, from this point A to point B, we suppose that the car, for example, is traveling at 30 meters per second. From point B to point C, say for example, it's traveling at 20 meters per second. From point C to point D, say for example, it's traveling at 15 meters per second. So in this case, the speed of the car is changing along this road from points A to B, B to C, C to D. So the speed is changing, and it's important to define the average speed of all of these three speeds, which is given by. Then let me define the average speed. So let me here suppose that this is A, this is B, this is C, and this is the point D. Okay. Then the average speed is given by Vm is equal to the total distance d divided by the duration delta t. So now we all know what is meant by delta t. Delta t is equal to t2 minus t1. So we know how to calculate delta t. So Vm is equal to d divided by delta t. Whenever we introduce a formula in physics consisting of three variables related between multiplication and division, we can construct a triangle. So constructing the triangle of this formula, here because we have divide, then Vm will be at the bottom, so we can place Vm here or here. So we usually place it on the left. So this is Vm, and in this case d will be at the top and delta t here. Now let me introduce each quantity with its corresponding SI unit. Then Vm is set to be the average speed, and the SI unit of the average speed is given by meters per second. And its symbol is given by meter per second. D is the total distance, and the distance is given by meters. Its symbol is given by m, and we know that delta t is the duration. We know that the duration in the SI is given by seconds. Now in this case, we have expressed Vm in terms of d and delta t. Now suppose that we are interested in determining d, so putting our hand over d, then d is given by Vm multiplied by delta t. And if we are interested in determining delta t, so putting our hand over delta t is given by d divided by Vm. And I repeat that the SI unit of these quantities, the distance is expressed in meters, the duration delta t is expressed in seconds, and Vm is expressed in meters per second. Okay, so whenever we know two of these quantities, we can calculate the third quantity. So if we refer back to this document, d represents the distance from A to B to C to D. So this is the distance d, total distance d of the road, and the duration delta t can be measured using a stopwatch, and in this case we can calculate the average speed of the car, which is given by d divided by delta t. Okay, so let me consider the following example. So let me say example number 1. Suppose that d is equal to 100 meters and delta t is equal to 10 seconds. We are interested in determining the average speed, which is given by Vm. Then we know that Vm is equal to d divided by delta t. The value of d in the SI is given by 100. The value of delta t in the SI is given by 10. Now plugging this fraction on the calculator, now Vm is given by 10. Since both d and delta t are expressed in the SI, which is meter, and this is second, so the unit of Vm will be meters per second. So in this case, Vm is equal to 10 meters per second. Now also, if you consider another example, now suppose that Vm is equal to 30 meters per second, and delta t is equal, say for example, 5 seconds. We are interested in determining the distance d. We know that the average speed Vm is given by d divided by delta t. So here in this case we are interested in determining the value of d. So constructing the triangle of this formula, here because we have divide and Vm will be at the top, d here, delta t here. We are interested in determining the value of d, so putting our hand over d, then d is given by Vm multiplied by delta t. Now the value of Vm is given by 30, the value of V is given by 5. Plugging this on the calculator, then the value of D is given by 150. Since both Vm and delta T are expressed in the SI, so Vm is in meter per second and delta T is in second, so the unit of D will be in meters. So the distance D is equal to 150 meters. Let me also consider a third example in which now we should calculate the duration delta T. Now suppose that Vm is equal to 150 meters per second and the duration d is equal to 10 meters. We are interested in determining delta t. So as a first step, we write the formula, the general formula that relates Vmd and delta t, which is given by Vm is equal to d divided by delta t, knowing that we are interested in determining the value of delta t. So constructing the triangle of this formula, here because we have divide, then Vm will be at the bottom, d at the top, delta t here. We are interested in determining the value of delta t, so putting our hand over delta t, then delta t is given by d divided by Vm. Now the value of d is given by 10, the value of Vm is given by 150. Plugging this fraction on the calculator, then the value of delta t is given by 0.066. Now since d and Vm are expressed in the SI, which is meters and meters per second, so the value of delta t will be expressed in seconds. Then delta t is equal to 0.066 seconds. So here what we have seen is that the average speed can be calculated using this formula, whereas the instantaneous speed is usually measured by the speedometer. Now here, as we can notice from this document, here we have 2 units of speed, which is given by at least 2 units, which is given by miles per hour and kilometers per hour. So it's necessary that we define some units of speed and distinguish between them. Then here we have reached section number 6, which is given by units of speed. Then let me say that the SI unit of speed is meters per second. Which is denoted by meters per second. And other units of speed they are given by kilometers per hour, kilometers, say for example per second, centimeter per second, miles per hour, so on and so forth. Okay. Now, what about the conversions between these different units? So let me say section number 7, conversion of units regarding the speed. Then actually we are only interested in one conversion of unit, which is the following. In order to convert from kilometer per hour to meter per second, we simply divide by 3.6, knowing that the meter per second is the SI unit of speed. And in order to convert back from meters per second to kilometer per hour, we multiply by 3.6. So this is it for the conversion of units and the speed. Now notice that the average speed, which is given by Vm, which is equal to d divided by delta t. Now we have talked about the conversions of the average speed, which is Vm. We have talked earlier about the conversions of unit regarding delta t. Now it's left to talk about the conversions of unit for the total distance d. Then let me add section number 8, which is given by conversion of units regarding the distance d. And here also let me say the following. Here, when I'm talking about units of speed and conversions of units of speed, I'm not distinguishing between the instantaneous speed and the average speed, because these two apply for both of them. Now, here in this case, we are interested in two conversions. In order to convert from kilometer into meter, we simply multiply by 1000. And this K is similar to the one of the social media. For example, if we have 1K likes, it means that it is given by 1000 like, or in other words, we are multiplying by 1000. And in order to convert back from meters to kilometers, we simply divide by 1000. Now, in order to convert from centimeters to meters, we divide by 100. And in order to convert back from meters to centimeters, we multiply by 100, okay? So in this case, let's solve exercise number 5, page 62, as a direct application on what we have explained. So they are telling me in this exercise to perform the following conversions. Then we need to convert from minutes to seconds. In order to convert from minutes to seconds, we simply multiply by 60. In this case, 10 minutes, which is equal to 10 multiplied by 60. So this is given by 600 seconds. So the missing number here is given by 600 seconds. Now, as for kilometers per hour to meters per second, in order to convert from kilometers per hour to meter per second, we simply divide by 3.6. Then 36 kilometers per hour, which is equal to 36 divided by 3.6, and this is given by 10 meters per second. Okay, so the missing value here is 10. Now, as for 5 hours, we need to convert hours into minutes, knowing that each hour contains 60 minutes. Then we simply multiply by 60. Then 5 multiplied by 60, and this is given by 300 minutes. Then the missing value here is given by 300. Now, in order to convert from kilometers per hour to meter per second, we simply divide by 3.6. So 72 kilometers per hour, dividing 72 by 3.6, plugging this on the calculator, we got 20, then 20 meters per second. Then here the missing value is given by 20. Now, as for 3 hours, we need to convert hours into seconds, and we know that this is done is by multiplying by 3600. Then 3 multiplied by 3600, this is given by 10,800 seconds. Then the missing value here is given by 10,800. Now in order to convert from meters per second to kilometers per hour, we multiply by 3.6. Then 340 meters per second, which is equal to 340 multiplied by 3.6. Now this is equal to, if we plug it on the calculator, it's given by 1224 meters per second. Then the missing number here is given by 1224 kilometers per hour. Sorry. Now 2 hours 15 minutes need to be converted to seconds, knowing that from hours to second we multiply by 3600, and in order to convert minutes into seconds we simply multiply by 60. Then 2 hours 15 minutes, knowing that each hour here contains 3600 seconds, and each minute here contains 60 seconds. Now plugging this expression on the calculator, then this duration corresponds to 8,100 seconds. Now as for the speed, which is given by 1,500 meters per second, knowing that in order to convert from meters per second to kilometer per hour, we simply multiply by 3.6. Then 1,500 multiplied by 3.6, then the value of this speed is given by 5,400 meters per second. Here the missing value is given by 5,400, sorry, kilometers per hour. And here the missing value is given by 8,100 from the previous part. Now as for the duration, which is given by 4 hours 10 minutes 20 seconds, we need to convert this duration into seconds, knowing that each hour contains 3600 seconds, each minute contains 60 seconds. Then 4 multiplying it by 3600, 10 multiplying it by 60, and as for the seconds, it is already in seconds. Now plugging this expression on the calculator, then we have that the duration d expressed in second, the duration delta t expressed in second is given by 15,020 seconds. Then the missing value here is given by 15,020 seconds. Now here for the final part, let's change this and make it kilometers per hour. It's more convenient according to our explanation. Then 30 kilometers per hour, we need to convert it to meter per second, and this is simply done by dividing by 3.6. Plugging this on the calculator, then the value of the speed is given by 8.33 meters per second. So the missing value here is given by 8.33. Now this is it for exercise number 5, page 62. Let's consider another exercise, which is exercise number 7, page 63. The title of this exercise is Unbeatable Record. Women's world record in 100 meters in athletics was set on July 16, 1988 by Florence Griffith Joyner in 10.49 seconds. And now here must be very careful. So they are telling us that the women's world record in 100 meters. So what does this quantity represent? Always reading quantities can be done by referring to the unit. So notice that this quantity has the unit of meter, and we know that the physical quantity having the unit of meter is the distance. So the total distance t is equal to 100 meters. So no need to convert this to the SI because it's already in the SI. Okay, they are telling me by Florence Griffith Joyner in 10.49 seconds. So what does this quantity represent? Since it carries the unit which is seconds, then it represents time. And here it's important to distinguish between two times, the instant time and the duration. So whenever in the exercise they give us a single time, this is said to be the duration delta t. If they gave us two instant times, then for sure they will be talking about the instant time t1 and the instant time t2 that are separating an event from the starting of the event till the end. Okay, so in this case, this number represents the duration and not t1 and t2. So delta t in this case is given by 10.49 seconds. And the event in this case is given by the race. Okay, now before I continue the question, notice that we have the distance and we have the duration delta t. So which physical quantity can we calculate using these two is the average speed, which is Vm given by d divided by delta t. Okay, now if we refer back to the exercise, they are telling us calculate the average speed in meters per second, so it is the SI of a Florence during this race. Okay, so let's start by writing the average speed is given by, so in physics we always start by writing the formula, which is given by Vm is equal to d divided by delta t. Notice that in this case no need to construct a triangle because this is the quantity that we want to calculate. Now the value of d is given by 100, which is already in the SI, and the value of delta t is given by 10.49, which is already in the SI. Now plugging this fraction on the calculator, then the average speed of this woman is given by 9.53. Since d and delta t are expressed in the SI, so the value of Vm will be expressed in the SI, which is meters per second. Then the average speed of a Florence is given by 9.53 meters per second. And by this we have finished solving this exercise. So that's it for me in this video, guys. See you soon on another one.